Hello students, we are going to discuss the lecture 9 of the water pollution and control. Already we are discussing about the water pollution and control. This is the continuation of our previous class and this is lecture number 9. So myself Ananya Bormor, Assistant Professor, Department of Chemistry, JS College of Engineering. So today we will discuss about the BOD, the biological oxygen demand. Okay, so biological oxygen demand is the important, very important, one of the important parameter by which we can measure the quality of water, right? Now also we will see how we can determine the BOD of a water sample. If you are given a water sample, so what will be the BOD of that water sample, that you can easily determine by 5 days BOD test, that is 5 days BOD test. Now why this is 5 days? Because we assume that this 5 days is enough for complete decomposition of the biodegradable material. That's why we are taking the 5 days test. Okay, so generally what will happen, before 5 days we will measure the dissolved oxygen, and after 5 days we will measure again the final amount of dissolved oxygen, and from that if we subtract the final value from the initial value, so what will happen, we will get how much amount of oxygen is dissolved oxygen is required for the reaction, for the BOD reaction. Okay, and that is obviously the BOD, the calculation of the BOD. So let's start the class. Okay, so as I told you, this is the continuation of the previous class, that is water pollution and control, and lecture number is 9. Okay, so the core subject name is environmental studies and subject code is BCA102, BCAN102. Okay, so these are the some of the course objective for this course. That is, after you will be able to understand the natural environment and its relationship with the human activities. You can also able to apply the fundamental knowledge of science and engineering to assess the environmental and health risks. You will be able to understand environmental laws and regulation to develop the guidelines and procedure for health and safety issues, and also you will be able to solve the scientific problem solving related to air, water, noise, land, okay, the pollution. So these are the some of the course objective that we have. Next, these are the course outcome that we have for the environmental studies. That is, after this course, you can understand the natural environment and its relationship with the human activities. You can also apply the fundamental knowledge of the science and engineering to assess the environmental and health risks. You can develop some of the guidelines and procedure for the health and safety issues, which is obeying environmental laws and regulation. And also you can able to acquire some of the skills for the scientific problem solving related to air, water, land, noise. Okay, so these are the some of the course outcome that we have. Now come to the today's objective. So today we will discuss generally that is we will see the procedure of the modified BOD test as well as the procedure of the previous BOD test. Okay, also we will see how to calculate the BOD of a given water sample, and we will solve some of the problems. So already we have done the calculation, but this portion is very important, so that's why I'm again repeating this portion, because there are so many problems, there are so many questions you may have in your exam from this portion. So that is why you must have the clear idea how to solve the problem, how to determine the BOD of a given water sample, what will be the procedure, what are the precautions that we have to measure. So all this you should remember, you should note down, because this is very important topics in this chapter. Okay, so that's why I am again repeating. That is the BOD test. We will first see the previous BOD test, then we will see the procedure of modified BOD test, then we will calculate determine the BOD of a given water sample and solve some of the problems. So these are the some of the objective of today's class. Now, what is BOD? BOD means, that is biochemical oxygen demand or biological oxygen demand. Any term you can use. Okay. Now, BOD means what? The demand of dissolved oxygen. So, demand of dissolved oxygen. Why you require this dissolved oxygen? For the decomposition. Now, for decomposition of which material? For decomposition of biodegradable materials, waste materials that is present into our water sample. So for this reaction, whatever dissolved oxygen we require, this dissolved oxygen we require, that is called by the BOD, biochemical oxygen demand or biological oxygen demand. Okay, so in our water we are having like biodegradable waste, like waste paper we may have vegetable waste, dry leaves, dead bodies, kitchen waste. So these are all food waste. So these are all organic or biodegradable waste. Now for their biodegradable, that means they can decompose into the nature. So for their decomposition we require some of the dissolved oxygen. Why dissolved oxygen? Because these biodegradable materials are present into the water. So in water we are having the oxygen in dissolved condition. So that is why we are using this term, that is dissolved oxygen. So with the help of this dissolved oxygen, it will transform into the carbon dioxide and H2O. That carbon dioxide, after formation, it will be evaporated. Okay. Now here in this reaction, the microorganisms are the acting as the catalyst. Okay, very important. Microorganism here acting as a play very important role, because this is the catalyst. Catalyst means in any reaction, the positive catalyst generally we are using to increase the rate of the reaction. Okay, so this is the importance of using the microorganism. Microorganism means in water if we have bacteria, virus. Okay, so presence of that microorganism, what will happen? The biodegradable material will decompose with the help of with the reaction with the dissolved oxygen into carbon dioxide and water. So for this reaction, whatever dissolved oxygen we require, that is called by the biological oxygen demand or biochemical oxygen demand. Okay, understand? Now we will see what is the procedure. Sorry. Okay, so now we will see what is the procedure that we can apply for determination of the BOD of a given water sample. If you are given one water sample and if you have to determine what is the BOD, biological oxygen demand, for that water sample, the how can we do that? By the 5 days BOD test. Why 5 days? Because 5-day we assume that 5 day is enough for complete decomposition of the waste materials that is biodegradable waste materials present in water. So this is 5 days BOD test. Actually what we have to do, first of all we have to collect the waste water. Okay, and we keep the water into the 300 ml stoppered bottle. Now, why stoppered bottle? Stoppered bottle, generally what will happen, these reactions this reaction is taking place with the help of dissolved oxygen, right? Now, if we don't use the stoppered bottle, then aerial oxygen will come to the bottle, and whatever we are getting the we will measure the the amount of BOD, that will be the erroneous. So that is why first of all we have to use a stoppered bottle, so that the bottle will be closed, so that no oxygen molecule can enter into the bottle from the outside, from the environment. Okay, so the sample, what we have to do, then the sample dilute, we have to dilute the wastewater sample with the water, diluted by the water. Now, why this dilution is required? Because if we don't dilute our sample, if we use the concentrated sample, what will happen, we require, for the decomposition of that much biodegradable material, we require around 100 milligram. Okay, 100 milligram per liter of dissolved oxygen, that much we require. But in our water only we have the limited amount dissolved oxygen, that is the saturated value. Ideal condition, in ideal condition we have the saturated value, that is 9 milligram per liter, that is very less amount than the 100 milligram per liter. That is why first of all we have to after collection of that wastewater sample, we have to dilute that wastewater sample with the water. Okay, now initially we measure the dissolved oxygen and then keep the bottle into the dark place for 20 degrees centigrade, at 20 degrees centigrade for 5 days. Now, why this dark place? Okay, dark place, why? Because this BOD reaction is very much light sensitive reaction. Okay, if light is in presence of light, it will produce a free radicals, so that is why it will be interference in the BOD reaction, and we cannot get the perfect result, the correct result. Okay, so that is why what we have to do, we have to prevent this light sensitive reaction, and that is why we have to keep the bottle in a dark place. Okay, and after 5 days, we finally measure the dissolved oxygen, which is DOF. Now 5 days, now the so this is the all over the reaction. In this bottle number 1, we have taken the 300, this is the volume of the bottle is 300 ml. We have taken the wastewater and diluted water for dilution water. Now we have seen the initial amount of dissolved oxygen, which is DOI, and we keep this bottle for the 5 days at 20 degrees centigrade in a dark place. So after that, again from this bottle we take the we have to take the sample, and then we have to measure the final amount of dissolved oxygen. So that time the BOD will be DOI, dissolved oxygen initial, minus DOF, dissolved oxygen final, divided by P. What is P? P is the dilution factor. As we have diluted our sample, that is why here we have to incorporate some of the dilution factor, that is P. P value is volume of wastewater divided by total volume. As we have taken here 300 ml, that means the total volume will be the 300. So why we will solve the problem? First of all, you have to check whether the volume is 300 or not, and according to that you have to put the data. Understand? So this is all over the previous preliminary test of the 5 days BOD test. Now these tests we have to modify, because in this test we have used the water, but we we don't consider the BOD of the water. So in our next modified test, we have considered that water also having some BOD, and from total BOD we have subtracted the value BOD of the water, and that time we will get the actual BOD of our wastewater sample. Okay, now modified test, all the things are same, only we have to keep two bottles. First bottle, both bottles, the volume of the both bottles are same, that is 300 ml. In the first bottle, again we have to take the wastewater and diluted it with the water. And in bottle 2, only we have taken the water, diluted water, not the dilution water or the water whatever we have used for the dilution, and not the wastewater sample. Only bottle 2 contain the water. Now what will happen, the first of all, for both bottles we have to take the initial volume, initial dissolved oxygen for the both bottles. Okay, like for this, for bottle 1 that is DOI, and for bottle 2 that is BI. Now we have to keep the bottle into the dark place at 20 degrees centigrade for 5 days, and after that finally we have to again measure the dissolved oxygen amount, which is DOF and BF. Okay, so these are the same procedure we will follow, only we have to take in this case the two bottles. One bottle is wastewater plus diluted water, dilution water, and second one is only filled with the water, not the wastewater we will take in our bottle 2. Okay, next, so this is a procedure. You can see two bottles are there. One bottle is wastewater plus diluted water, but dilution water, and second bottle is only water is taken. And the initial values are this one, DOI and BI. After 5 days, the final value is DOF and BF. So the modified test, this is the very important equation, the modified BOD 5. Okay, so from the modified test, the BOD 5 will be DOI minus DOF minus BI minus BF. As such, DOI minus DOF means the BOD. It will give you the BOD of the bottle 1, that is total BOD. Total BOD means wastewater plus water, right? And this is BI minus BF. This is as such BOD of the bottle 2. That means this is this will give you as such the BOD of the water. So total BOD minus water BOD. So what you will get? You will get the actual BOD of the wastewater into 1 minus P, where P is the again dilution factor, and that is equals to volume of wastewater divided by total volume. Okay, so this is the procedure of the modified test. So that for that modified test you have to remember the equation. Now we will see how to solve some of the problems. Okay, so if we practice the problems are very important and very easy. If you practice the problem then regularly, then you can know how to solve the problem, and you will be able to score much more. Okay, understand? So now problem number 1, a wastewater sample of 25 ml. Okay, so 25 ml wastewater we have taken. By adding 275 ml seeded dilution water. Seeded means seeded dilution water. Seeded, why seeded means nothing else, we have added some of the additionally microorganisms so that the reaction will be completed. That is why that water is called by the seeded dilution water. Now DOI is given, that is 9 milligram per liter, and after 5 days DOF is also given, that is 3 milligram per liter. If the seeded dilution water has initially BI is also given, that is 10 milligram per liter, and BF, that is the final value of the water, that is bottle 2, excuse me, BF, that is 8 milligram per liter. Okay, Now you have to find out the BOD5. That means obviously this is telling about the modified test. That means we have to use this equation. While you are solving the problem, first of all you have to check the question very well. What are the data are given, right? So according to the data, you have to choose the equation number 1 or equation number 2. Money the previous equation, the preliminary preliminary BOD test or the modified test, which one you have to choose. That is depending on the data, whatever data you are given, right? So here according to the data we have to use this equation. So all the data are given. DOI is given, that is 9 minus 3 minus 10 minus 8 into 1 minus 0.083. What is 0.083? That is the p value. P value means what? That is the volume of wastewater. Here we have taken, that is 25 ml, right? P equals to 25 ml divided by total volume. Total volume what? That is 25 ml wastewater plus 275 ml seated dilution water. So total volume will become 25 by 300. So this will give you the p value, right? And that is 0.083. So if you do this, then we will get the answer. The answer is, that is 50.19 milligram per liter. Okay, so the unit of the BOD is, that is milligram per liter, because BOD is nothing else but the amount of dissolved oxygen required for the BOD reaction. So we know already that the unit of the dissolved oxygen is milligram per liter. So obviously the unit of the BOD will be milligram per liter. Understand? So this is the first question. Thus you can solve the first question. Okay, now we will move to the second question. Hopefully you understood that how to solve this type of problems. Very easy. All the data are given. Only you have to memorize which equation. Identify first which equation you have to use, and then just by memorizing you have to write down the equation. Understand? Okay, next question we will see, that is, in a 5-day test, the dissolved oxygen level drops by. Very minutely, carefully you have to check the question. Dissolved oxygen level drops by 1 milligram per liter of seated distilled water. A 300 ml BOD bottle filled with 21 ml wastewater and the rest seated diluted water, okay, shows a drop of 6 milligram per liter in the same period, that is 5 days period. So what will be the BOD5 of the waste? Now look here. So the whatever data are given, that is drop, the dissolved oxygen drop. Now how we can get this dissolved oxygen drop? By obviously, if we know the initial value, if we know the final value of the dissolved oxygen, so initial minus final if we do, then that time we can know how much oxygen is dropped, and how much oxygen is used up for the reaction. Okay, that means here you can see no initial value, no final values are given, only the drop of dissolved oxygen is given. That means this the drop of dissolved oxygen means initial, they have done already the initial minus final, and that value is given. Okay, so that means, look, 1 milligram dissolved oxygen level drops by 1 milligram per liter of seated diluted water. That means this is the dissolved oxygen level drop for the bottle 2. Bottle 2 means where we have taken only the water. Okay, so that means Bi minus Bf, that is equals to 1 milligram per liter we can write down, because if we do the initial minus final, that time only we can know the drops of dissolved oxygen level. Okay, so again, a 300 ml BOD bottle filled with 21 ml wastewater and the rest did diluted water shows a drop of 6 milligram per liter in the same period of the 5 days. So, for the again we have the second drop of the dissolved oxygen, which is for the bottle 1, where we have kept the wastewater plus this diluted water. Okay, so now that means DOI minus DOF obviously should be the 6 milligram per liter, right? Now what is the p value? P value means the volume of wastewater divided by total volume, right? So here we have taken volume of wastewater, that is 21 ml, divided by total volume. Total, what is the total volume? That is 300 ml. So 21 divided by 300, this will give you the p value. Now look, p value don't have any unit, because this is the ratio of two volumes. Volume ml by ml, volume by volume, that means volume will be nullified. So p, the ratio, this is the ratio of volume, so that is not having any unit. Okay, now how to solve this? So for this exactly we have to use the modified BOD test equation. So this is the actual equation, that is 6 minus 1, because DOI minus DOF. Okay, that is 6 minus 1 into 1 minus 0 0.07. 0 0.07 is the p value, divided by 0 0.07. If we do this, then we will get this is the answer, that is 72.43 milligram per liter. Okay, so this is the answer, milligram per liter. So this will be the BOD 5 of the wastewater. So this type of question also you may have, where the individually the initial and final values are not given, the drop of dissolved oxygen value is given. So drop of dissolved oxygen means the initial minus final. If we know the initial minus final, that will give you the drop of dissolved oxygen. Okay, understand? So this type of problem you can solve like this way. Next, move to the next problem. Yeah, next problem is the BOD 5 of a sample of wastewater is found to be 325 milligram per liter. The initial DO of diluted wastewater is 20 milligram per liter, and the test requires a decrease in dissolved oxygen at least 4 milligram per liter with at least 3 milligram per liter of DO dissolved oxygen remaining at the end of the 5 days. So you have to check this question very minutely. There are so many data are given. Look here, the initial dissolved oxygen is given, that is 20 milligram per liter, right? Then it has written that test requires a decreasing dissolved oxygen. Again, decreasing dissolved oxygen, that is initial minus final. If we do, that will give you the decrease in dissolved oxygen. Okay, so that is at least 4 milligram per liter with at least 3 milligram per liter of DO remaining at the end of the 5 days. That means this 3 milligram per liter, that is your final value. So initial value you know, final value you know. So here now you can see here the for the bottle 2 no data are given. That means we have to use here the preliminary equation. Okay, which is BOD 5 equals to DOI minus DOF divided by P. That means 20. DOI initial value is 20 and final value is 3. That means 20 minus 3 divided by P, and which will give you the P value. Now, what we have to find out? We have to find out the range of dilution factor. Range. While you are having this type of question, the range of dilution factor, that means you have to find out two values of dilution factor. Like if your dilution factor, one factor is 5 and one value is 6. So what will be the range of dilution factor? That 5 to 6 will be the range of dilution factor. Understand? So that is why if you have this type of question, that means you have to provide two values. You have to calculate two values for which you require two equations. So one equation is this one, and another equation, look here, the 4 milligram. What is 4 milligram? That is decrease in dissolved oxygen. That means that is initial minus final. So we can write down like this: BOD 5 equals to 4 by P, right? And that is P equals to BOD 5 is already given, that is 325 milligram per liter. So you can that means you can very easily calculate 4 by 325, that is another P value. So here is your range of P value, range of dilution factor. Understand? So while you are having the range of BOD, you have to find out range of dilution factor. That means you have to find out two values, otherwise you cannot know the range. Understand? So next question. Yeah. Next question, the dilution factor of an unseated mixture of wastewater is 0.04. Dilution factor is given, that is 0.04, right? And the DO of the mixture is initially 9 milligram per liter, and after 5 days it dropped to 3 milligram per liter. Now find out the 5 days BOD of the waste. Now what are the values are given? P value is given, dilution factor is given, right? And the initially the 9 milligram per liter, that means the initial value is given, and also after 5 days it dropped to 3 milligram per liter. Final value is also given. So this is very easy question. So we have to use the preliminary equation. That is the previous equation, that is BOD 5 equals to DOI minus DOF divided by P, while initial is 9 and final value is 3 divided by P value. P value is already given, that is 0.04. So the answer is 150 milligram per liter. So this is very easy question. Only you have to put the data into the correct equation, and then you will get the correct answer. Okay. Yeah. Okay. So these are the some of the types of problems that you may have, you frequently have in your exam. So you have to solve the problems and practice the problems regularly. Otherwise, you just forget about how to solve this type of problem. Very easy. Only you have to put the data, and only you have to check the question very well, because in some question you may have this type of sentence like decreasing dissolved oxygen, drop of dissolved oxygen. So that time the direct initial or final value are not given. Okay, so initial minus final value, rather initial minus final, that value is given. So that you have to find out, that you have to understand to solve that problem. Okay, now I have given one question for the quick review, how much you have got this chapter, this topic. So which one is acting as a catalyst in BOD reaction? Now you know the what is BOD reaction, and for this question you will get the 10-second time. So your time starts now. Yeah, your 10-second time is over, and you're absolutely right. The answer is microorganisms. The microorganisms actually acting as the catalyst. Without this microorganism, the reaction cannot taken place. Okay, so this is the answer. Now This is the recapitulation. Whatever we have discussed, we have discussed the procedure of BOD test and also procedure of modified BOD test we have seen. Also, we have calculated the BOD of a given water sample, and we have solved some of the problems, BOD reactions based on the BOD reaction. Okay, so these problems are very common. You may have in your exam. So this portion of the water chapter is very important. So that's why I'm again repeating ki, just you have to practice the problem very well, understand regularly, otherwise you cannot solve the problem is very easy, and each and every problem will carry 4 to 5 marks. So it's very easy to score the marks if you know how to solve the problem, and only it will happen that time if you are regularly doing the practice. Okay, so thank you students, follow the classes regularly and do the assignment whatever I have given you and submit it in time. So see you in the next class.